So next up we have Ryan from Metaio, who's going to be telling us about their AR SDK for wearables.
Hello. Hello, my name is Ryan Burgoyne, and I'm with Metaio. So today I'd like to talk to you a little bit about Metaio's SDK and how it can help you to make awesome augmented reality experiences, specifically for wearable devices. So as a brief introduction to Metaio, we've been doing augmented reality for the last 12 years, and computer vision really is our core competency. And we're constantly doing research and development into new tracking types and new types of experiences. So and then when we have created these new tracking types, we're able to integrate them into our products, which include Metaio Creator, the Metaio SDK, and our Metaio Cloud services. And our applications are used in large content distributions such as IKEA and Audi, which have deployed these AR scenarios across the world. So there's a lot of different options that you have available to you with the Metaio SDK. So I'm going to break them down for you a little bit here. First of all, we have the option to write AR experiences using JavaScript that run cross-platform on any of your devices. So when you create a JavaScript-based application, you can do that either by coding in JavaScript directly yourself or using our Metaio Creator tool, which I'll talk about in a minute. That application can be directly exported as an application to run on Android, iOS, or Windows. But you can also upload that augmented reality HTML and CSS and JavaScript content to your own web server or to Metaio's cloud, where then from another app that uses the Metaio Cloud plugin, you can access that content. The neat benefit of this is if you, say, deploy an application that's going to have regularly updated content, and later you want to change the content in the application, you don't have to release a new update for people to download. All you do is change the content in the cloud, and then the users will automatically be able to access the new content. On the other hand, in some situations, you might want to access features that are part of the native SDK of the platforms you support. Like you might want to use the speech recognition features in Android, or some of the unique native features of iOS. In that case, you can directly use the APIs for Android and iOS, which allow you to code in Java or Objective-C for those platforms. So it's really flexible what you're able to do. Finally, if you create one of those cloud apps that use JavaScript, you can use our Junaio browser to access it on devices without them having to install a standalone application. One of the really neat things about Metaio's software is the huge variety of tracking options we provide. So we do offer some of the basics, like ID markers, QR codes, and GPS to give you basically geolocation information. But we also support 2D image tracking, and we also do 3D map tracking. So basically, you can use an application on your mobile device called Metaio Toolbox to create a 3D map of a certain environment or a room or a large environment, and use that to augment your content and track your location. Another ability with the Metaio SDK is that if you don't know exactly where this augmented experience is going to be happening, you can use our Instant or SLAM technology to create 2D or 3D maps on the fly. So the user of your application can simply scan the room and will automatically create a 3D map for the augmented reality to occur no matter where they are. Or they can, if they have any 2D image without a specific 2D image that you want to track, they can take a picture of that image and it will be used for augmented reality. We've just recently introduced in our latest version of the SDK, which was released this week, we've introduced face tracking as well, and that's going to continue to be improved to add augmented reality to tracked human faces. So we're really excited about all these different possibilities that we have for different tracking types. Now, I know that all of you are really excited about the upcoming wearable space, and so are we. So we've implemented features to make our SDK compatible with wearables. We support the Vuzix M100, Google Glass, and also the Epson Moverio BT200. Some of the features that are most key when it comes to wearables are these. You need to have see-through rendering. What this means is on a normal mobile device, when I hold up my phone or my tablet to see an augmented experience, I see the camera view on the screen and I see the augmented content overlaid on top. But when you have glasses, I'm already seeing the scene in front of me. I don't need a camera view rendered there. I don't want to have a picture of what I see in front of what I see and then the augmented content. What we need is the augmented content directly overlaid on the real world. And so that's what see-through rendering is all about. We get rid of the camera feed, have just a clear view of the real world, and put the augmented reality content on top. Now that's how we do it for Google Glass, but for the Epson glasses, they actually provide 2 screens for stereo rendering. And what that means is that instead of seeing a flat image on the world in front of you, you can see a 3-dimensional image that actually integrates with the world. So as you move around, you see this object that stays in place as if it was really there. And for that, we need to do stereo rendering, which means that the left eye and the right eye see a different picture to give you a sense of depth. And so that's something that we've already integrated into our SDK. And finally, see-through calibration means that if we're going to look out at the real world and see the augmented reality, we need to have those 2 line up. They need to be the same size and the same position so that you're really convinced that you're looking at something real. And so all of these things are included in our SDK that we've just released this week. And so we're really excited to announce this. We've got some other really exciting features. One of the new types of tracking that we released recently is called edge-based tracking. One of the things you might realize as you're working on augmented reality, especially with 3D tracking, is that you can run into challenges with specific types of surfaces. We were working with Volkswagen to create an application for augmented reality in their car, and we are struggling because the car's surface is so shiny. The surface doesn't have really any features, and when you're doing 3D tracking, what you're tracking is the marks and the features on the surface. And especially a shiny surface is very difficult to track. So we came up with a solution called edge-based tracking that instead of tracking marks on the surface, only tracks the edges of the doors and the wheels, etc. And how it works is you create a 3D model of the object's edges, and it snaps into place on the object. I'll show you a video of how this works. So you can see there's a 3D line model, and as soon as they lined it up with the car, the augmentation snapped into place. And so you're welcome to come out to our booth today and take a look at this. We'll have a car there that you can check out how this edge-based tracking works. We're really interested in always doing new research to advance the state of the art. And we've been working really hard on this, on the use of depth cameras to enhance augmented reality. So one of the problems that we deal with in augmented reality is when you're looking out at the world, you put some augmented content on top of it, then something comes in front of it, and it should be blocked. It should be occluded. For example, I'll show you in this video. If you look at this room, we want to put a chair in the middle of the room, and that chair needs to be blocked by the table. Normally, with augmented reality, the chair would be in front of everything, and it wouldn't look like it was integrated into the room. But in this case, we're using our proprietary tracking and reconstruction technology as well as a depth camera to create a 3D map of the room in real time and overlay this proper occlusion onto the model to make it really seem like it's there in your room. So it's exciting technologies like these and advancements that really set Metaio apart. Another feature that we have is continuous visual search, which can track up to 1 million images and respond in near real time. So these images can be uploaded to our cloud service, and then they can be tracked up to 1 million images through Metaio continuous visual search. One thing that's really exciting about Metaio's SDK is that it's free to get started. All you have to, you can download our SDK and Metaio Creator for free, and you can publish an unlimited number of apps using a Metaio watermark for free. So the starter version is completely free to use. And I'd just like to show you an example of an application that has been designed for wearable augmented reality. So first I'm going to disable the wearable features and I'll show you what it looks like. So this is standard image tracking. You can see that as I hold up this image, the image of the spaceship is projected onto it. Now, with just those 3 lines of code, it sets stereo rendering on, so a different image for each eye. It sets the camera to see-through, and it sets the background color to black so you can see through it. And now what you'll see is there's 2 different images, one for each eye, and you only see the augmentation. So if you were to use this on the Moverio glasses, for example, you would see the object sitting on top of this image like it was part of the real world. I'm really excited about augmented reality and the potential that these new wearables provide. And so I hope you'll take a look at the Metaio SDK as you're evaluating your options for the SDK that you want to use. Thank you very much.
Okay, we have time for a couple of questions. Anyone? No? I have one up there.
You mentioned about image occlusion and,
Yes.
and that you had the capability to do it. I think yesterday you said something about having some specialized hardware. Can you describe that again?
Sure. So the question is if we need special hardware to do the occlusion in real time. So the video I showed you was from our research lab. That feature with the occlusion hasn't been released in our SDK yet, but it does use a depth camera, an infrared depth camera, to determine the distance to objects. And so when that is released, you will need special depth camera hardware in order to do that in real time.
Do you know when?
I don't have an announcement for the date yet.
Hi, I created a published a project for my class, and one of the things I noticed is that despite having all the diverse types of tracking that you offered, you can only pick one, and that's it. Has that changed with the new update, or that's how it is?
Great question. So his question was whether you can use different kinds of tracking at the same time. In the current version, and the way things stand, you can choose a single sensor type. You can have multiple images, for example, but you can only do image tracking, or you can only do 3D tracking. We do offer some fusion of sensors, specifically the sensors on your device, such as gravity and rotation, can be used to enhance the other types of tracking, but at this point you can't mix and match sensor types. So I hope that answers your question.
Hi, how the see-through calibration is done?
So could you say your question again?
See-through calibration, how to do it? Like the user does it, or is that automatic fashion?
Great. So the question was, how is the see-through calibration done? Currently, for known device types, that calibration is built into the SDK. So for the Epson glasses, there's a built-in calibration. But there's also commands available. You can ask me afterwards, or look on our development website, and it will explain the process of the user giving development calibration commands as well.
Great. All right. Well, thank you, and a round of applause for Metaio.